Newton's third law is tragically misunderstood. The statement's simple enough. Every action has an equal and opposite reaction, but it doesn't really go far enough because it doesn't describe what the action and the reaction forces really are. And it's that second one, the reaction, that's usually misunderstood. I'm sitting here at my desk. I've got forces acting on me. So I've got my weight acting down, and then I've got a contact force from the chair holding me up, acting upwards. So I'm in equilibrium. I'm not moving up or down. Those are not the action and reaction that Newton was talking about. I mean, it's confusing a little bit because we might call the contact force acting up on me a normal reaction force, but it's not the Newton pair that Newton was meaning. It's not what he's talking about at all. So what we're going to do now is we're going to try to understand what it is he is meaning, and let's define that reaction. Right, well, the bit that gets missed out is that Newton's third law has three criteria for the two forces, which we're going to call a Newton pair. The first is that the pair of forces must be of the same type. Now, this is kind of important, and it immediately crushes the chair example from above. My weight is a gravitational force. The chair pushes up with a contact force. They are not the same type of force, so they can't be a Newton pair. The second is that they must act on different bodies, which is another blow for the chair example. My weight is a force due to gravity that is acting on my body. The chair also acts on my body. They act on the same body, so they can't be a Newton pair. The third is that they both act in the same line. Well, my weight acts through my centre of mass, and the contact force from the chair might do as well, probably does. So that's not certain, seems okay though. But the Newton pair has to meet all three criteria anyway. So, what is the Newton pair for my weight? Try to have a think. When you think you know, use those three criteria to see if your answer fits. Pause if you need to, it's good to think. Well, my weight is a force due to gravity, so its Newton pair must also be a force due to gravity. My weight acts on me, so the Newton pair must act on something else. Actually, it's going to be a force I'm exerting on something else. And the Newton pair act in one line. Well, if you think about it, my weight acts in a straight line that extends from my centre of mass to the centre of mass of the Earth. So if you think about what weight is, weight is the force acting on me due to the pull of the Earth. And it acts towards the centre of mass of the Earth. Its Newton pair is the force acting on the Earth due to the pull of my body that acts towards my centre of mass. They're both gravitational forces, they act on different bodies, and they act in the same line, just opposite directions. Every action has an equal and opposite reaction. Lots of people get this wrong, but there's no reason that you should be the same. Just make sure you apply those criteria each time and remember the fact that you're going to have to deal with the same type of force. Now, there's not many forces in the universe, and actually all you're going to have to worry about really are going to be gravitational forces and contact forces, so just think that part through. And apply those criteria with a little bit of care and precision, and you should be fine.